All right, good morning, ladies and gentlemen. We have 3 weeks to go. 3 weeks, you should be able to get this done. Those of you who are paying attention, great job. Keep it up. Those of you who need to start working. Okay, you have 3 weeks. Let's get it done, people. All right, so you can transform polynomial functions in the same way you have transformed other functions throughout this class. So we have done this, ladies and gentlemen, a couple of times. Again, remember, with the horizontal translation, it's x minus h, so our h is going to be 5 units right on our example, because h is equal to 5. On this one here, remember, it's x minus a negative 2. So on this one here, our h is negative 2, so that would make it left. Remember, on a vertical translation, it graphs it up and down, and it goes with the sign. So if it's plus, it's up. When it's minus, it's down. A reflection, remember, if it's on the inside, it's over the y-axis. If it's on the outside, it's over the x-axis. A horizontal stretch or shrink, okay, again, it will be on the inside here, so f of a times x, and that's going to be, remember, that's an opposite, so if it's 2, it shrinks by 1/2. If it's 1/2, it stretches by 2. So remember, on those horizontal ones, we flipped it, and then a vertical stretch or shrink, again, it's on the outside, so we would take it and we would say it's 8, it's a stretch the same way, it's a shrink the same way, so a shrink by 1/4. Okay, so example, describe the transformation of f of x cubed represented by g of x is equal to x minus 3 cubed minus 1. Then graph each function. All right, so let's go ahead and graph our function, our main function first, because again, that's something that we should remember. So on a cubic function, remember, I can write, we're going to have one at 0, 0. We're going to have one at 1, 1. And we're going to have one at negative 1 and negative 1. And remember, it's going to be a cubic function looks something like this. Okay. So now what I want you to do, the easiest thing for you to do, ladies and gentlemen, is to take the one at the origin and move it. All right. So I'm looking at the one here at the origin. Okay. I want to move that point, and then you'll see that it's going to basically be the same. So remember, I'm going to go minus 3, x minus 3. So if we remember up above, that's going to take it, what? 3 units right. So we're going to take that and we're going to go 1, 2, 3. We're going to be right there. And then we're going to go, remember, when it's a vertical translation, we take the sign. So we're going to go down 1. So we're going to go down 1. Okay. So that would now make our vertex be at 3 and negative 1. And remember, everything else on this one here will stay the same. So remember, on this one here, because we don't have any horizontal stretch or shrink or vertical stretch or shrink, so everything else should stay the same. So I'm going to go on this one here, I went 1 over and 1 up, so I'm going to go 1 over and 1 up, and I went 1 over and 1 down. I'm going to go 1 over and 1 down, and I'm going to make the same kind of graph. Okay, remember, I told you should label them. That one was F, and again, this one here was, and that one's F, excuse me, and the one in the red is G. So there are 2, and it said to describe the transformation. So I'm doing it at the end. It doesn't matter as long as you can see what it happens. And on this, we had a translation. Remember, we went 3 right. Okay, again, we went 1, 2, 3, and we went 1 down. And that's example 1. Okay. On to the next page. Example 2, describe the transformation of f represented by g, then graph each function. So f of x is equal to x to the fourth, and f of x and g of x, is equal to 3x to the fourth. So if we think about it, we have g of x is equal to, and kind of look at the ones it looks like. All right. So if we look up here, it has it on the outside. So we could write this as a times f of x, which is our a is equal to 3. All right. So if we think about that, what's going to happen? We're going to have a vertical stretch. And it's going to be by a factor of 3. And what I would suggest, try to graph it yourself, ladies and gentlemen, and then plug it in your calculator and see if you're right. So what you should notice on a to the fourth power function almost looks like a parabola. On sometimes it'll be more drawn out. On the bottom, it could almost look like something like that. But in this case here, you're going to see that it's actually pretty much parabola shape. All right. So that means that when it's 1, it's 1. When it's -1, it's +1. Now think, if I was to do 2, it'd be 2 times 2 is 4 times 2 is 8 times 2 is 16. So you know it's going to be clear up there, and it's going to be clear up there. It's actually going to be off my graph here. All right. So I'm going to go ahead and draw that one in for you. And remember, that is our f. I put that on there at the beginning this time. And then let's go to our g. Again, our 0, 0 is going to stay the same. When I'm at 1, now it's going to be at 3. And when I'm at -1, it's going to be at 3. So remember, on a vertical stretch, it should look narrower when the a is greater than 1. Remember, it would be wider if it's between 0 and 1, or a fraction. So I'm going to make a 1 right there, and there's my g. All right, so those two were pretty easy. Now this next one, it's still kind of the same thing, okay? So we just did an x cubed term from the previous one, so let's go ahead and put that one in there, okay? So again, remember that was at 0, 0, 1, 1, -1, -1. And remember, it kind of looked something like this. There's our f on our g, okay? And again, on these ones here, you can always put what your vertex was. So on here, our vertex is at 0 and 2. And I want you to think that's the one that you're going to move, all right? So remember, 1 times 1/2, all right? So when I take my ones here, okay, I'm going to take, and my 1 at 0, 0 times 1/2 is 0, right? And then plus 2, that will give us, our vertex is now at 0 and 2. All right, which is what I just told you, okay, even though I have it in the wrong color. All right, and then our other ones, again, if I take that, I'm going to have, our other one will be at, again, I'm just going to plug in 1, and then I'm going to add it, and that would make it at 2 and 3. And then our other one would be at -2. and 1. And again, we're still going to have the same kind of thing here. Again, you could have just plugged it in, but we're going to have one that looks, again, it's still going to curve. So basically, I just took our 3 points again. Here, let me go ahead and write this one down for you. I told you it was at 2 and 3. And this one here is at -2 and 1. Remember, this was a horizontal. Stretch, because remember, it was on the inside, so we had 1/2. But remember, since it's horizontal, it went to 2. All right. So again, 2 times 1. All right. And then by a factor of 2. Okay. That's what we did first, and then 2 up. So again, just think I used the 3 points that were similar on that one here. Okay, and we have one more like that. Okay, I modified the homework a little bit, so you did do a couple of each one, some that are a little more involved than the other ones. All right, so on this one here, let f of x equal x to the 4th minus x cubed minus 1. Write a rule for g and then graph each function. Describe the graph of g. On A, we have f of x. G of x is equal to negative f of x. So remember, that's going to say it's equal to the negative, all right, of x to the, sorry, once in a while, it likes to make my thing a polygon. Sorry about that. So x, okay, let's just erase those two and try again. It's equal to negative x to the 4th minus x cubed minus 1. Remember, when it's on the outside, what is going to happen there? I want you to think about that. We're going to distribute that through. We're going to have negative x to the 4th plus x cubed plus 1. And remember, the negative on the outside gives us a reflection over the x-axis. And on this one here, it's kind of a little funky graph. So let's go ahead and I'll show you what it looks like here. All right. So I know I have one at 0 and 1. I know I have one at 1 and 1. All right. And then I have another one here at 1 and -1. So and then it kind of looks like this. So I'm going to go through here. All right. And if you graphed it, it kind of goes like that. Makes a little hump there. And then we go like this. Again, it doesn't have to be perfect. I'm not looking for perfect. Perfect will happen in pre-calculus. So remember, we just said it was a reflection over the x-axis. So again, you're going to kind of do the same thing here. So on this one here, this one goes, again, you're going to reflect it to here. I went to the x-axis. I went one more over. On this one here, I went to the x-axis. I went one more over. On this one here, I went to the x-axis and went over. So those are the 3 points we had before. And we kind of want to do the same thing. So on this one here, we're going, and on this time here, your hump's going to go towards the x-axis. And you should have something. Again, it's not perfect, but it does show you what we're doing. So that was a reflection over the x-axis. And it looks a lot better on my drawing than the way it does on yours. All right, and then the last one here is 0.3 f of x. So remember, on these ones here, what you have to think is it a times f of x? Or does it look like f of a times x? And again, that's the question you would ask yourself. Okay, let's make our question mark look a little better for you. And you would tell me it looks like this one, so we wouldn't worry about that one. So we're going to take our 0.3. I'm going to take x to the fourth minus x cubed minus 1. And that'll give us 0.3 x to the fourth. Sorry, getting rid of my parenthesis there. Minus 0.3 x cubed minus 0.3. And remember on this one here, since it's a times f of x, that will be a vertical shrink. By a factor of 0.03. Okay. Again, let's go ahead and draw our original one. It's the same one as it was up here. So we had one here, here, and I had one here. And it went like, wait, sorry, I had it over too far. It's going, oh, it's going to look nicer. But now I know why. So again, there's our f. And on this time here, again, this one's going to stay the same. It's just going to make it be 0.3. All right. So let me go back to the color. And it should look something like this. Remember, it's going to go and make it wider. So it's going to be like right here and right here and right here. It's not perfect on this one. Again, you're just choosing points. You know, it's going to go underneath. It's going to hit a little there. And this one was probably the hardest one for me to draw too, ladies and gentlemen. You can always, if you're not sure, you can make a table. But again, you could graph it and look at the table there using your Desmos calculator. All right, so today's is kind of a lot of graphs, but you've done a lot of graphs before. Tomorrow's will be easier for you. I promise only 4 problems. But this one here, it's still not that many problems, and you can do it. Thanks, everybody. Miss seeing you. I'm not going to lie to you there. All right. Have a nice day. Get your homework done.